Okay, good morning class. So today we're looking at quadratic equations and inequalities. So today we're going to look at exercise 2.16, quadratic inequalities. These are the examples for exercise 2.16, and exercise 2.16 is on page 60. However, the examples on page, the first example is on page 51. Okay. So quadratic inequalities. So inequalities is basically there's more than and less than sign. Quadratic, the highest power on x is basically 2. Okay. So the question says solve for x squared is less than 16. X squared is less than 16. So the first step is to get this into standard form. So that's step 1. Get it into standard form. So what is standard form? Ax squared plus bx plus c is less than or equal to 0 or less than 0 or more than or equal to 0 or more than 0, whatever. That's the first step we need to do. Right, then we factorize the trinomial. Factorize the trinomial. Okay. And then we graph the solution, and then you write it in inequality form. Okay, for those of you like following steps, that's the steps you will be following. First we write this in standard form, which is ax squared plus bx plus c, which is the standard form of a trinomial. Then you factorize the trinomial or the quadratic. Supposed to have said factorize the quadratic, that's a better, because sometimes it won't always be the trinomial. So rather write quadratic. Factorize the quadratic, then graph it, and then your inequality, you write the solution of the graph in inequality form. Okay? Right, so let's address this question then. So, we would first need to write this in standard form. Is it in standard form? Yes. No. We must have 0 on the other side. Can you see that? So what do I do first? Take a 16 over. Okay. If I take the 16 over, what do I get? X squared minus 16 is less than 0. Next step is to factorize the quadratic. Difference of 2 squares. Not so. So what do I get? X and x. 4 and 4. 1 plus 1 minus. Okay. Now you see that x plus 4 and x minus 6 must be less than 0. What does less than 0 mean? Must be negative. Now you see there's a point on a graph where something changes from positive to negative. Can you see that? If something changes from positive to negative, okay? Or someone is living or dying. No? There's a stage, we call that, and that's called you say somebody's in hospital. Then we say he is, before he's dying, he is critical. No? If somebody's critical, he's between life and death here. He's almost going to die. Not so? Likewise, if something is positive or negative, there's a point where it is going to change from positive to negative, like a 0 value. And that is what we call the critical value. You guys understand? So the critical value of this graph, where does this change from positive to negative? At -4. It's like I'm solving for x here. Can you see that? When does this change from positive to negative? At positive 4. So you ask yourselves, okay, now why didn't I just say x is equal to -4 and x is equal to 4? That's a question you should be asking yourselves. And the answer to that is because this is not equal to 0. So I can't say x is equal to -4 and x equal to 4. If I had said x is equal to -4 and x equal to 4, that means to say that are solutions to the graph, to the equation. Can you see that, people? So what do I say? It's a critical value, or the 0 values, is at -4 and 4. So it's that if I solve this product, and I solve that product. People, what does this remind you of? Okay, let's just take one step back. If I wrote y is equal to x squared minus 16, what would that remind you of? Exponential. Parabola. Yes. Not so. And when do we solve for x? When do we solve for x? When we're calculating what of this graph? Not everybody at once. Just one person. Huh? When do we solve for x? X-intercepts, yes. We calculate the x-intercepts. So these critical values, in other words, are my x-intercepts. Correct? Is this parabola smiling or frowning? Smiling. So what I'm going to do is I'm not going to draw the y-intercepting. I'm just going to draw the x-intercept, because that's all I need, is the x-intercept. You see the parabola smiling and it's cutting at two places. Can you see that? What is this going to be -4 or 4 on the side? -4. And it's going to be 4. You all understand? Have I lost any of you yet? You with me, Amber? Your name Amber? Yeah, I got it right today. Come with it. People, this is the x-axis. What's the equation of the x-axis? Y is equal to, yes, why? Zoe is on the board today. You guys must play some time with them. Huh? Nice, I like it. People, this is your 0 value, where your y is equal to 0. If something is above this line, is it going to be positive or negative? Positive. This means where your y-axis is positive. So then that means to say that this part of the graph is positive. Can you see that? So in other words, this is where the function is more than 0. Positive means was more than. Not so. So this is where the graph is more than 0. And if it's below the line, it is where it is less than 0. Can you all see that? Who's confused? If something is above 0, positive. If something is below 0, negative. Can you see that? So this is what we call more than 0, and this is less than 0. You guys understand? So just taking one step back to grade 8. Read this inequality for me. X is? Oh, you guys know that. X is greater than 2, no? Or X is? More than 2. It's the same thing. Now read this one. Oh, you guys know this. I thought I was going to catch you out. Okay. So X is greater than or equal to 2. It means the same thing, but this one is inclusive. You guys understand? Right. Read this inequality. X is greater than -2 and X is less than. Right, you guys understand this, no? I think we did this last year as well. Yes, okay, makes sense. So, reading this inequality here, the This is like the function. This here is that graph there. Okay, can you see that? So in other words, we're going to look where the function is less than 0. So in other words, we're going to look where the function is negative. If this had to be positive, if this had to go the other way around, then we would have looked where the function is more than 0. Then we're going to look where the function is positive. Simple, no? Right. So, where's the function less than 0? Is less than 0 above or below the line? Below. So it's this part that we need to consider. You see, this part is below 0 here. So is this continuous or a break-in solution? Is it together or is it apart? It's together. It's from minus 4 to 4. So if it's together on the graph, we write it together. So we say x's in that direction. X's more than negative 4, but x's less than 4. If you had to be equal sign, I would have put equal and equal. You guys understand? Is there anybody that's confused? So do it again. Yes, Michael. Do it again. Okay. Right, so the question says solve for x squared is less than 16. I'm not going to take the square roots both sides. For the sum. So what we do is, we must write it in standard form first. How do we write it in standard form? Taking 16 over the inequality. So x squared minus 16 is less than 0. Next step, what do we have to do? Factorize the quadratic. Okay, so we say the difference of two squares is applicable. So you've got x and x, 4 and 4, 1 plus 1 minus. Okay. Then we're going to look for CV, which is what? Critical values. The 0 values, in other words. My critical values are, where is this giving you 0? Negative 4. Where is that going to give you 0? What do we do now? We represent it on the graph. Because this is x values or your 0 values, I'm only interested in the x-axis. Okay? You got minus 4 and 4. So this is the y is equal to 0 line. This is more than and that's less. That will always be the case. So this tells us is where the function is less than 0. Less than 0 means negative. So it's just part of the graph. So the question was, is this continuous or break-in solution? Continuous. It's from one point to the other point. There's no break here. Can you see that? So it's from negative 4 to 4. That's an x, negative 4 and 4. We always put a smaller one on that side. No? Then the inequality will always be written in that direction. You don't write it the other way around. You don't make both going to the x or both going away from, no. Always written like this, if you're going to have the smaller one on the side. You guys understand? In other words, x must be? X must be? More. If it's open to the x, it's more than. So x must be more than negative 4, and x must be less than. More than negative 4, but less than. So is that one. You guys understand? Okay, let's do another one. Let's look at example 2. Example 2 is on page. What? What's he say? Stronger, guys? You want bread? What's stronger? Milk? Oh, that is why the guy look at the shop and he's like, you are pointing to the bread and he's saying milk. You got a friend at the shop, he's teaching me these things. It looks like he's teaching me wrongly. People, example 2 is on page 53. So you awake today, Mr. Kanu? The geometry is making you sleep, you see.
So what's that word?
What word? Under? Inequality. The inequality form. Example 2, we are asked solve. You got x squared minus x minus 6 has to be greater than or equal to 0. What's the first step there? We must get it in standard. Is it in standard form? Yes. Factorize the quadratic. What type of factorization will take place here? Trinomial. So, we go. It will be x and x, 3 and 2, minus 1. Now, I know some of you use the quadratic formula. Not so. If you use the quadratic formula, you go straight into critical values. What will this give you a value of 0 for? 3. And this one here? So if you use the quadratic formula, you do the substitution, and then you say critical values is 3 and minus 2. You don't have to show this. Alright, you guys understand? So what do I do next? Graph the solution. Not so. These are what? X values. Is this graph smiling or frowning? Smiling. We take it just before the critical value. Sometimes it's a negative here. But when we divide it by a negative, what happens to the inequality? Change, it swaps around. Not so. So we will always draw the graph smiling. Alright, you guys understand? Let's go. Graph is smiling. What is this x value here? Negative 2 and 3. Why the negative 2 on that side? Because that is more negative on that side. Not so. So this is the y is equal to 0 line. This is more than n. So what does this inequality say? The function must be greater than or equal to 0. So what does that mean? It is where the graph is. Something is greater than 0. It's more than 0, which is also what? Positive or negative? Positive. So in other words, it's that part and that part of the graph here. Not so. So it's there and there. So is this, from negative 2 must go in that direction, correct? To cover this part of the graph. And 3 in that direction to cover this part of the graph. Now, is the solution together or is it apart? It's apart. It's a break-in solution. Can you see that? The solution is apart. So will I write the inequality together or apart? Apart. You guys understand? So if you can get this right here, then the inequality is going to be easy. Okay, so we write it apart. So I write x, negative 2, or x and. So we go in this direction now. Is this more than or less than? Less than. Can you see that, people? I'm going to the negative direction. So it's less than. So x must be. Now must the inequality be open or close to the x? Close. So x must be less than and equal to negative 2. You see that, people? Or in that direction, x must be more than or equal to. Okay. Any confusion? Any confusion? No? But the next one, I think we must just pick up the pace a bit. This is number 3. Example 3 is on page 3. Is this in standard form? Yes. Then we must factorize this trinomial. Again, if you're using the quadratic form, you go straight into critical values. Okay? So I'm going to do it here using the formula. I know that what it's going to be is going to be 2 and 1 and 1 and 3 in the brackets. Okay? Okay, so 2 and 1, and yeah, 1 and 2. But anyway, if you use the formula, it's going to be minus b plus, your critical values, of course, it's going to be minus b plus minus the square root of b squared minus 4ac over 2a, which is now going to give us critical values of 7 plus minus the square root of negative 7 squared minus 4a, which is 2, and c is 3 over 2a. Okay, so your critical values in this case is going to be, so we put the 7 plus the square root of negative 7 squared minus 4 times a times c over 2 times 2. Again, as I've indicated before, do not put x is equal there. So you are going to assume is a solution. You're going to lose a mark there. Okay? So your x value is going to be 3, and I think it's going to be half in the negative. Oh, no, positive. Yeah. People, you guys understand? So there we factorize the quadratic. We got 0 values. So what do we do now? We graph it. The graph smiling or frowning? So where do we check? Just before we do the critical values. No? The graph is smiling. What value goes here? Oh, and here? As you can see, 3 is more positive than now. Okay. This is y is equal to 0. Above that will be positive, and below that will be negative. You guys understand? So read inequality. Where the function is greater than 0. So in other words, we're going to look where the function is positive. So positive is above the line. Not so. So it's this part of the graph, and it's that part of the graph. Okay. So as you can see, that's going to infinity as you can do that way, and it's going negative infinity and positive infinity. You see that, people? So, is the solution apart or together? It's apart. So it's a break-in solution. Not so. So what do I write? X and half or x and 3. But this is going in that direction, not so. So x must be less than half. Is it equal there? No. So it's just less than half or greater than. Right. Yes, Michael. Yo, I thought you were going to ask me something mathematical. Yes. Sorry? What's he saying?
How do you know that the graph is
apart together? You see that because we highlighted this and that part there. Can you see that? So is the solution apart or is it together? You see that one is going in that direction, that's going in that direction. So it's apart. In number 1, the solution was actually together. There was a continuous solution there. Hence the reason why we wrote it together. Can you see that? So in other words, if it's less than and it's here at the bottom and it's together like that, then it will be together here. Okay? Anything else? Yes? Nothing big? No? Yes?
how is x less than half?
Okay, so if we look at the questions, how is x less than half? If we look at this at the half here, which direction are you going? In the more than or in the less than direction? Less than. That is why x is less than half. If we look at 3, is this going in this direction, which is, can you see, to get this part of the graph, we're going in that direction. That is why x is more than 3. Okay. Is there any other confusion? No, not yet. Okay. Let's go to example 4. Sorry? Example 4 is on page 56. Right. So example 4, what must we do first? Get in standard form. Not so. So how do we get this in standard form? By writing negative 4x squared plus 25 must be greater or equal to 0. Now what we do? Divide by negative 1 because we want x squared to be positive before we factorize. Not so. This factorize, so divide by negative 1 or multiplied by. So it's going to be 4x squared minus 25 must be less than or equal to 0. Don't forget to change the inequality when you multiply or divide by a negative number. So what do we do now? What type of factorization here? Difference of 2 squares. So what's the square root of 4x squared? Square root of 25? Now what? CV, critical values. So what's for which value of x is that going to be 0? Negative 5 over 2. And the other one? What do we do next? Draw. Draw smiling or frowning? How do you know it's smiling? Here's the negative. We take it just before. Just before the CV. You can actually look there. And it was positive. You see that? So we're always going to draw the graph smiling. Okay. So this value is here is going to be negative. And this one? So this is y is equal to 0. This is more than and less. So this is the inequality. The function must be less than and equal to 0. So less than equal to 0, is that positive or negative? Negative. So it's this part of the graph here. You see that, people? Is that solution together or is it apart? Together. So the inequality must also be together. In other words, x must be, you got x negative 5 over 2 and 5 over 2. The inequality will always go that way. Okay? What do you notice here? Equal sign as well. So it must be equal. So this is the inequality. X must be greater than or equal to negative 5 over 2. That is in that direction. But x must be less than or equal to 5 over 2. It's in that direction. Right? You guys understand? Simple mathematics. The sum is worth 4 marks. Okay? Number 5. Example 5 is on page 58. Right. So, is this in standard form? Yes. Factorize a trinomial. This is a perfect square trinomial. So that actually works out to be x minus 9 squared must be less than or equal to 0. What's my critical values here? Critical value of 9. There's only one solution. So what does that mean? So only going to cut the x-axis once. It's a 2-in-1 solution. This graph smiling or frowning? Smiling. Smiling at 9. Yeah. So the bounce of the graph. But we'll do more of this in graphs. This is the y is equal to 0 line. This is more than n. Right. So what does this say? X must be, or the function, sorry, must be less than and equal to 0. So in other words, is where the function is less than 0, which is negative. Hang on. There's no part of this graph at the negative. So if this was just the function is less than 0, then there's no solution. But is there a part where the function is equal to 0? Yes. Where? at 9. So the solution is, therefore, x is equal to 9. Can you see that, people? It's only at x is equal to 9 where this inequality actually exists. If it was where the function is less than 0, then you would have written no solution. Yes, Michael?
So you said 9 exists because it's below the
No,
bottom.
it's on 0. Isn't? She's saying the 9 is at the bottom. The 9 can be written there. It just indicates that it's that point. Okay, that's x equal to 9. You guys understand? See, any other confusion? No? Look at number 6. No, number 6. So on Monday we're going to look at solving problems using quadratic equations. For homework is exercise 2.16. You do for me. You do the odd numbers. Okay. And then on Monday we're going to look at some word problems. Okay. The full lesson can be found in the description box below.